4 through Anatomy and Physiology of Organ Systems. This lecture we will do a brief introduction of the circulatory system. So let's hop right in. The circulatory system consists of a pump, fluid, and a series of conduits. In animals, the muscular pump is the heart, the fluid is the blood, and the conduit is the blood vessels. Blood carries oxygen to the tissues, so blood must be relatively close by. So animals typically have a large number of blood vessels found throughout their bodies. Figure 32.1 shows the blood vessels of the kidney. As you can see, it is quite the vascular organ. Indication of the circulatory system is correlated with an animal's metabolic rate and their need to circulate oxygen rapidly. Oxygen transport is critical as animals cannot tolerate long interruptions without oxygen. Mammals and birds have high rates of blood flow compared to lizards, frogs, and fish, due to mammals having higher metabolic rates. A closed circulatory system is a system with blood that always remains within blood vessels. A heart pumps blood in arteries, which branch into smaller and smaller vessels. And these vessels become microscopic in size. As blood leaves tissues and organs, it flows into larger and larger vessels, the veins, and back to the heart. Figure 32.1 shows a general diagram of vessels of a circulatory system. As blood flows from the heart and arteries, this blood is oxygen-rich. It will travel to tissues and leave the tissues and go to the veins, which take the blood back to the heart. Tissue cell. Capillaries are the principal site where blood releases oxygen, nutrients, and hormones to tissues, and take up carbon dioxide and other waste products from the tissues. Alright, here's our first progress check. Take your time to answer these pressing questions and continue on with the lecture when ready. Next, we're going to look at a couple of different pathways of blood through the body. In animals, systemic tissues are all the tissues and organs other than the breathing organs that take up oxygen from the blood and add carbon dioxide to the blood. Systemic circuit is the pathway of blood to and from systemic tissues. Breathing organs add oxygen to the blood and take up carbon dioxide from the blood. The breathing organ circuit are blood vessels that carry blood to and from the breathing organs. Arteries and veins are defined by the direction of blood flow. Arteries carry blood away from the heart, while veins carry blood toward the heart. Perfusion refers to flow of blood through a tissue or organ. In fish, the systemic and breathing organ circuits are connected within a series. In fish, before the blood becomes oxygenated, it must pass through the gills to receive oxygen before moving to the rest of the body. All the blood pumped to the gills is oxygen depleted, having just exited the systemic tissues. Crustaceans, squids, and octopuses also have similar circulatory plans. Figure 32.5 illustrates several different types of circulatory systems found within animals. As mentioned before, in fish, blood is pumped from the heart, then to the gills, before moving to the rest of the body. Contrast that in mammals, as you can see in the top right. Blood is pumped to the lungs, where it becomes oxygenated and moves back to the heart, before being pumped to the rest of the body. In mammals, blood passes twice through the heart before going to the systemic tissues, whereas fish, blood goes through the heart once, then to the systemic tissues. Within animals, the heart is completely divided into right and left halves. Alright, here's our next progress check. Take your time to answer the questions and move on with the lecture when ready. Next, we're going to talk about the heart. I want you to know the flow of blood through the heart for the final exam. A heart is a discrete, localized pumping structure. Myocardium is the muscle tissue of the heart. Mammals and birds have 4 chambers with one-way valves to ensure that blood flows in the correct direction through the chambers. Heart has 4 chambers. Flow of blood through the heart is as follows. The right atrium receives oxygen-depleted blood, then the blood flows into the right ventricle. When the ventricles contract, blood is pumped through the pulmonary arteries to the lungs. In the lungs, the oxygen-rich blood leaves through the pulmonary veins and enters the left atrium, and then passes to the left ventricle. When the ventricles contract, the oxygen-rich blood is pumped through the aorta to the systemic tissues. Please note the flow of blood through the heart, where it is oxygen-poor and oxygen-rich. Also on the slide, note any bolded structures. Here's the circulatory system in humans. The heart pumps blood to the lungs, where it becomes oxygen-rich, and then pumps it to the rest of the body. When the oxygen is depleted in the blood, it returns to the heart to become oxygenated again. This diagram traces the flow of blood through the heart. Blood enters through the superior and inferior vena cava and goes into the right atrium, then to the right ventricle, before moving to the lungs via the pulmonary arteries. It returns to the heart via the pulmonary veins and goes into the left atrium and left ventricle before leaving through the aorta to travel throughout the body. Flow of blood is reliant on the cardiac cycle. The cardiac cycle is a cycle of contraction and relaxation of the heart. Systole is when ventricles contract, and diastole is when the ventricles are dilated or relaxed. As the ventricles relax, blood flows into the chambers. As the ventricles contract, it pushes blood out of the chambers to tissues throughout the body. Arteries carry blood away from the heart as it contracts. Slits in the heart, called ostia, act as one-way valves that allow blood to move back into the heart. Contractions pump blood to arteries as relaxation allows the heart to be filled again through the ostia. Alright, here's our last progress check. This was a relatively short lecture. As mentioned before, you must know the flow of blood through the heart. Take your time to understand it before answering this question. Let me know if you have any questions, and have a good rest of your day.